All right. Hey, thanks for joining in. Today we're going to talk about perfect square equations, how to solve them, where they are on the graph, and how many solutions they are. All right, here we go. So this is a perfect square equation. Notice how it's a perfect square and it equals a number. So right here, this is our perfect square. X plus a times x plus a. The length and the width are exactly the same, and therefore it creates a square. All right, now these are some forms that we've seen, but these are not perfect squares. This is called factored form, and the length and the width of our area model are different. And so this would form a rectangle, not a perfect square. Right? This is standard form, and this looks at the inside area of that area model, and it's in the form ax squared plus bx plus c, also not perfect square form. And down here, we see an example of something that is really close to perfect square form. But in order to be considered perfect square form, it has to have a perfect square on one side of the equation. And here it's close, but there's this c that's in the way. This c value needs to be moved to the other side so that we end up in perfect square. If we could move that c to the other side, we'd have x plus a squared equals and a number on the other side. So to be a perfect square, it has to be something, a quantity squared on one side of the equation. All right. So if we have an equation in perfect square form like we do here, to solve this, we undo the square by taking the square root of both sides. All right. Here's what that looks like. When we square root the left and we square root the right, the squareds actually cancel. The square and the square root cancels, and we end up with just x plus 5. There's no more squared. There's no more square root. They cancel each other out. And on the right side, we end up equaling 7. Everybody knows the square root of 49 is 7. But did you know that the square root of 49 is also negative 7? Negative 7 times negative 7 is 49. So we end up with two solutions, one that is positive and one that's negative. All right, now we solve this equation. We subtract 5 from both sides. We get x equals 2. And on the other side, we get x equals negative 12. All right, so check this out. Here's where we see these on the graph, 2 and negative 12. We see these here at the x-intercepts, 2 and negative 12. There they are. Okay, let's look at another example, one that's not a perfect square. We do the same first step. We square root both sides, which leaves us with x plus 5 equals. Now 48 does not have it's not a perfect square, so it doesn't have a square. So we just leave it as square root of 48. We'll leave it right there, radical 48. But don't forget that there is still a second solution to the square root of 48, and that's negative radical 48. All right, we subtract 5 from both sides, and we just leave the radical there. It's okay. All right, and our second equation, we get negative square root 48 minus 5. Now, notice the difference here. On the left's equation, we were able to simplify the square root 49 into just 7. Over here, we weren't able to do that, so we just leave it as a radical, and that is okay. All right, now, where do we see these solutions on our graph? We see them right here at the same place as the x-intercepts. Now, it makes sense that these would be really close to the values that we had over here. It's not quite 2 and negative 12. It's 1.9 and a negative 11.9, which should make sense because the square root of 48 is really close to the square root of 49. Okay, but in terms of the way their answers look, these are very different. Okay, let's look at a couple other cases. All right. What happens if it equals 0? In this case, 0 is not positive or negative. It's just 0. So when we take the square root of both sides, we end up with x plus 5 equals 0. There's no positive 0, no negative 0. So there's just one equation. And we solve that equation, we get x equals negative 5. All right, which on our graph, we can tell this parabola just touches right here at negative 5, just one time. That's it. All right. Now let's look at what happens if we equal a negative number. We square root both sides. Same step. All right. We get x plus 5 equals. What's the square root of negative 9? Now this is an interesting question. 3 times 3 is positive 9. Negative 3 times negative 3 is also positive 9. There's no way that we can multiply something by itself and get negative 9. So this has no solution. And on the graph, when we look at this parabola does not come down and touch the x-axis. It has no x-intercepts. All right, so here's a summary for you. There are two solutions when on the other side of the perfect square, it's a positive number. There's one solution when on the other side of the perfect square, it's a 0, and there's no solution when it equals a negative number.